In this video, we are going to be learning how to classify matter and reviewing chemical symbolism. Matter is anything that has mass and occupies volume. All matter is made out of atoms. We can classify matter into different categories based on how the atoms within the matter are arranged or connected. All matter can be divided into two main categories: pure substances and mixtures. Pure substances can either be elements or compounds, while mixtures can either be homogeneous or heterogeneous. When deciding whether matter is a pure substance or a mixture, it can be helpful to think about whether the composition is variable. For example, tea with sugar is a mixture because it can contain different amounts of sugar. Water, on the other hand, is a pure substance. Every sample of pure water consists of H2O molecules. However, the water that comes out of a faucet is not considered pure because it contains many dissolved minerals and other substances. Pure substances can either be elements or compounds. Elements are made out of only one type of atom. For example, all the atoms in this picture are helium atoms, represented by the same color. Compounds form when two or more different types of atoms are chemically bonded together. In H2O, there are two hydrogen atoms bonded to one oxygen atom. In CO2, there are two oxygen atoms bonded to one carbon atom. To separate a compound into its component elements, a chemical change must occur. An element is already as simple as matter can get, so it cannot be broken down into simpler substances. This is a reminder that subscripts in a chemical formula tell us how many atoms of each element are bonded together in the smallest piece of that substance. In the first picture, we have individual nitrogen atoms that are not connected to each other. The smallest piece of this substance is represented by the symbol N. In the second picture, we have three molecules, each consisting of two nitrogen atoms bonded together. The smallest piece of this substance is represented as N subscript 2. The subscript 2 tells us that each molecule contains two nitrogen atoms. The third image shows two molecules of NH3. Each molecule contains one nitrogen atom bonded to three hydrogen atoms. Remember that subscripts of 1 are not written in a chemical formula. Elements can exist as individual atoms or as molecules. Some elements are atomic elements, meaning the substance consists of individual atoms. Other elements are molecular elements, meaning the atoms are bonded together in groups. You are responsible for knowing the 7 elements that naturally exist as diatomic molecules. The word diatomic means 2 atoms. The 7 diatomic elements form a number 7 shape on the periodic table, starting with nitrogen that has an atomic number of 7. Moving across to group 17, and then downward through iodine. The diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. There are also mnemonic devices that can help you remember these elements without a periodic table. One example is horses need oats for clear brown eyes. Another is have no fear of ice-cold beer for those of you over age 21. Here's a practice problem. Write the chemical formulas for the molecules shown. These are ball and stick models, where the atoms are represented by balls and the bonds between them are represented by sticks. In chemical formulas, the elements are typically listed from most metallic to least metallic. These molecules do not contain any metals, so all of the elements are nonmetals. However, elements further to the left and lower on the periodic table are generally written first. For the first molecule, there are 2 black carbon atoms, 6 white hydrogen atoms, and 1 red oxygen atom. The chemical formula is C2H6O. For the second molecule, there are 6 fluorine atoms and 1 sulfur atom. Sulfur is written first because it is further to the left and lower on the periodic table, giving us the formula SF6. In an earlier video, we discussed physical and chemical properties. It is important to recognize that the properties of a compound can be completely different from the properties of the elements that make up that compound. For example, sodium metal is a soft, silvery metal that can be cut with a dull knife, and it reacts strongly with water. Chlorine gas is toxic at relatively low concentrations. However, when sodium and chlorine react, they form sodium chloride, which is table salt that we eat safely on our food every day. Mixtures contain 2 or more substances physically combined together in variable amounts. Homogeneous mixtures appear uniform throughout and may appear to be a single substance because they are mixed evenly. Heterogeneous mixtures are not uniform throughout and may contain visibly different parts. Look at the 4 pictures shown on the slide and classify each one as a heterogeneous mixture, homogeneous mixture, element, or compound. The first picture shows many identical molecules, and each molecule consists of 2 atoms of the same element. Since all particles are identical and contain only one type of atom, this is a pure element. The second image also shows many identical molecules, meaning it is also a pure substance. However, each molecule contains 2 different types of atoms, so this is a compound. The third image shows 2 different types of molecules. Since the particles are not all identical, this is a mixture. The last 2 examples are both mixtures, and the difference between them depends on how well they are mixed. The third box shows separate regions, making this a heterogeneous mixture, and the fourth box is more evenly mixed, making this a homogeneous mixture. When using chemical symbolism to describe mixtures, plus signs are used to separate the chemical formulas of the different substances within the mixture. Numbers are placed in front of a chemical formula to indicate how many of that particle are present. For example, if we had 5 apples and 3 oranges, we could represent this as 5 apples plus 3 oranges. In chemistry, if we have 3 molecules of H2S and 3 molecules of Cl2, we can write this as 3 H2S plus 3 Cl2. The order the substances are listed in a mixture does not matter. Look at the 2 boxes below and provide the chemical formula or draw a picture to represent the chemical symbolism. The first box shows 3 molecules, each consisting of 1 circle and 2 triangles. This can be written as 3Ct2, or if you wrote 3T2C, that is also okay. For the second box, we need to draw particles that match the description 2S3C plus 3T2. This means we need to draw 2 molecules, each containing 1 circle and 3 squares, along with 3 molecules that each contain 2 triangles. Here's another practice problem. Identify each substance as either a pure substance or a mixture. The substances are steel, aluminum, air, coffee, soda, and table sugar, sucrose. Although steel may appear to be a pure substance, it's actually a mixture. There is no element on the periodic table called steel. Steel has a variable composition, and may contain iron, carbon, tungsten, and other substances in different amounts. Aluminum is the name of an element on the periodic table, so it is a pure substance. Air is a mixture of different gases. When you breathe, your body uses oxygen gas from the air and produces carbon dioxide. Air is primarily nitrogen, oxygen, argon, carbon dioxide, along with smaller amounts of other substances. Coffee is also a mixture because it contains water and many different molecules extracted from coffee beans during brewing. Soda is a mixture because it contains multiple ingredients, which can be seen on the ingredient label. Finally, table sugar, or sucrose, is a pure substance. Sucrose is a compound made out of carbon, hydrogen, and oxygen atoms bonded together into larger molecules.